And so we're going to drag all three cars to find out what the minimum is of those three. And then we're going to find out what the max is of the three. And then we're going to drag that over here. This symbol's downward is the minimum. So that would be the lowest car value, and this would be the highest car value. So once again, we'll do a test. Let's look at our data while the test is running. My biggest car, most expensive car is $19,000, and my cheapest one is actually 0. So we're going to assume that 0 counts. If this was a harder assignment, it would actually say, well, if the car is 0, let's not count it and say that his cheapest car is really $6,000. But that would take a lot more work. So here we load the output of the test, and we find out my highest car is 19, my lowest is 0. So we're getting quite along here. The next thing was the number of cars. So let's see if we have any hints on that. The number of cars. See hint number 8. Any car 1, 2, 3 value with a non-zero value will count as a car. Now, I didn't tell you what kind of functoid to use there, did I? So I think now we're going to have to do our first scripting functoid. So if you go down here to advanced scriptoids or advanced functoids, there's one called scripting. And we want to know how many cars he has. So we're going to copy all three cars as values to that. And then we're going to click here. And then there's another button down here called script. And the script property and button, or this, when I click here, there's an ellipse, which is sort of like a button. This only appears on the scripting functoid. So it actually opens a window where you can put in your code, and you choose your language here. And right now I think I'm a little more comfortable probably with C#. And so here it's building me a model, and we know we have 3 parameters. So we're going to change this to parameter 1, 2, 3, and they're not going to be strings, they're going to be decimals. Now what I would actually do in the real world, I would probably go write this C# code inside of Visual Studio, and then I would make sure it's working. I would unit test it there, and then I would copy just the function or the subroutine over here, and I would paste it in. So here we need to say something like if we need a counter. So we need an integer counter equals 0. Then we need to say if param1 is greater than 0. I'm not going to do all the normal indentation here. I'm just going to say counter plus plus. And I'm going to copy that 2 more times. So there's parameter 1, 2, 3. And now we're going to return counter. So I think that will work. So what we're basically saying is that any car that's not 0 or less will count toward the counter. And the counter will be incremented up to 3 times for a max of 3, a minimum of 0. And then the output of that scripting functoid will go over here to number of cars. And again, we do right-click test. And the answer is I don't actually see the result. So I'm going to make sure we did it here. Let's do the test again. Right there. There's an error. Cannot implicitly convert integer to string. So it's probably inside my C# routine. And so if we go back to my C# code, I think what was happening is it's returning a string right here. So this function, instead of returning a string, needs to return an integer, which is actually C#, it's just called int, right? So now again we test map. That's why I would test that code outside of the map in C# first, so you don't have these type of errors here. And now we have number of cars 2, so we got that correct. Congratulations. Okay, now we have just a few left. The average car value. So the average car value, it says C hint number 7. Use the mathematical divide and divide by 3. Add a constant with the value of 3. So earlier we did a sum here where we have the value, the total value of all 3 cars. And now if we want to divide that by 3, we just simply stick a divide sign in here. Take the plus sign into that, come here, divide by 3, and then take the output over here to the average. Now again, there's still a fallacy here that if they don't have all 3 cars, it's actually going to average in 0. So I would say if you really wanted to do it properly, you'd probably have to write a VB script for every one of these car manipulations. So we'll test that. And we're looking for car average $8,333. And basically what that should be is, do a sanity check here, it should be 25,000, the sum of these 2 cars divided by 3, which would be $8,300 each. So we're going to go back to the map. And now all we need is 2 or 3 more fields. The name of the first child and the name of the oldest child. So the name of the first child is hint number 1. We could use the index functoid on the advanced tab. That's not a very good hint, is it? So the name of the first child. Okay, so there's 2 ways to interpret this. Is it the name of the first child in the loop, or is it the name of the first child that was born to me? And I guess depending on how you interpreted it could be how you do this example. Let me just check out one more thing here. Yeah, I think I mean physically the first child in the loop. And then the oldest child, because I have a totally different hint for that. So the whole purpose of showing you the first child was to teach you how to use the index functoid. So we go down to the Advanced tab and look for index, and let's put it over here, and let's click on it and read what it does. It has only 1 input parameter. Use the index functoid to retrieve the value of a record or a field at the specified index in the source schema. The first input has to be a link from a record in the source. The rest of the inputs specify the index value of each level in the hierarchy. This functoid must have at least 1 input parameter. The maximum number of parameters is limited by the number of hierarchy levels in the source schema. So after reading that, that's actually the wrong functoid. So we have another functoid over here called iteration, and that will actually return to you what loop you're in. So if I want to know what's in the first loop, I can say copy the name of the first child. So let's take the name of the child here, and then if that is equal to 1, so now we need a logical functoid called equals. So this should return the number of the loop. If the number of the loop is equal to 1, then that will return a true. And then the logical functoids almost always go into a value mapping functoid. And if the first parameter of the value mapping functoid is true, then it says the second input is returned. So the second input will need to be the child's name. Then we copy that over here and we do a test. So the name of the name of the first child in the loop is Johnny. Now let's see if that's correct. Yeah, I think that does sound correct. So yes, Johnny was my first child in my loop. He's not necessarily the oldest or youngest, but he's number 1 in the array, basically. Okay, so that one's done. Now the next one is the name of the oldest child. So earlier we figured out what the age of the oldest child was, I believe, up here. So here we have the age of the oldest child. So if we backtrack down to here, we know the oldest child was 17 or something like that, right? So this is the number 17. So now if I do another logical compare, I know this is really weird the first time you see it. It's just like kind of bizarre. I want to compare 17 to the age of the child in the loop. So as it's looping here, I'm saying, is this child equal to 17? Yes or no? And then I loop again. Is the second child, is his age 17? Yes or no? And I loop again, and the third child, I say, is he 17? Yes or no? And so as before, the output of a logical functoid is almost always the value mapping functoid. So when this is true, I want to pass over that child's name. So in other words, if this child's name, if this child's age is equal to the age of the oldest child, therefore he must be the oldest child, and I want to take his name and I want to move it over here. Now you can see why this lab usually takes 2 hours for people to do during class. Okay, so now I'm going to save that and we're going to test again. Test map. Sorry, close that. Go to output, slide over here, control click, scroll down, and so the name, oh, I think we have an error here. Yeah, we do have an error somewhere here. The required field, okay, that's okay. Invalid loan points, that's okay. I don't see the name. Let me close all these little windows here. Okay, so let's do the test map again. And I don't see the name of the oldest child. So what happened is apparently it went through that loop, and every time it looped, it never actually returned anything. So let's go back up here. The age of the oldest child was 17. So let's go back and look at our logic now. Okay, one problem there is I got the youngest instead of the oldest. So that should have been the oldest child, not the youngest. The maximum cumulative age is 17. And I'm saying now if 17, if the age of this child is the same as the age of the max, okay, let's try that again. Test map. And it worked. Name of oldest child is Johnny. Now to really see if this is really working, I probably should change my test data a little bit. So here, what we're going to do is we're going to take Johnny and move him from being the first in the list to put him in the middle of the list. Okay? And so now the first child in the list is now Sally, but the oldest child is Johnny. Okay? So I just make sure I save my data. Close this. Go back to my map. Say test. And so name of the first child is Sally, and for some reason Johnny didn't show up. The only thing I want to make sure is I have all my windows closed that need to be closed. Sorry, just to make sure one more time, let's save this. Make sure I didn't make a dumb typo error here. And let's do test map again. also check to see if there's any major errors here. I don't see any. Click here. And we're not getting Johnny for some reason. Well, at this point, we're already 30 minutes into this video, so you're probably getting bored with that, and I kind of am too. So there are ways, of course, that we can make it work, but I'm not going to spend another 10 minutes trying to just get that stupid age of the oldest child there. We have one final thing to do, and that is the approved loan amount, and that is going to be 30% of the salary plus points times 1,000 minus your monthly debt. So we should be able to do this pretty quick. It'd be a good review of everything we've done so far. So we have 33% of the combined salary, I assume. So 33% of a salary would be a multiply. So we're going to take the combined salary, which was where? Okay, this is where we start running out of room. So see, I might need this functoid over here a little bit more. So I want to take this output. I can't get that far. So I have to get somewhere. I get this minus this time sign. Sorry. I need to get it in here where I can reach it somehow. So it's this plus sign. Goes into this time sign. And then we're going to multiply times 0.33, which is 33%. Then we're going to add the points times 1,000. So we already have our points over here, which is this fellow. So we want to add that times, what does it say? Times 1,000. So we need another multiply. So we're going to add basically this plus this minus this. So a couple ways we could do that. Let's take a plus sign here. And we want to take this multiply here plus that multiply minus some other number, which is going to be the monthly debt payment. So we need a minus sign now. Take that minus their monthly debt payment, and that should give us the approved loan amount. So again, I did that awful quick. I can't guarantee 100% sure that I did that correctly, but hopefully it gives you some ideas of how you can connect all these functoids. So I'm going to do a test again. And you can see we got some approved loan amount and we got the loan points here. So that pretty much concludes this map, which took us almost 40 minutes and shows a wide variety of the different functoids that are available. So just to recap some of the functoids that we used the concatenate quite a bit. We used trim. Of course, we used add, subtract, multiply, divide. We also used minimum and max on the car value. We also used cumulative minimum max to get the age of the oldest children. We used logical functoids to do if statements. And basically, again, the logical functoids always tie to a value mapping functoid, which is this one, which is on the advanced functoids. We also used the index looper, index iterator. And so this gives you a good idea of what a map could look like. And in the next video, we'll talk about maybe how you can rearrange this a little bit to make it cleaner.